Now, not all time series data is going to move in a nice linear fashion. Some have curves to them. The most common one is a curvilinear trend, which is revealed by an exponential curve. So we find these exponential trends in many financial models that have compounding, which if you are in finance or remember any of your finance formulas, you'll remember that they have the natural constant E, and that is what we consider an exponential trend. Therefore, we want to look for this exponential trend. Now, the exponential trend can be interpreted as a constant percentage change where each successive term increases by a certain amount, say 10 or 15%. And this begins to compound, and this is why this is widely used in banking and finance. When we experience an exponential trend, the errors aren't additive, they're multiplicative, which means the errors are multiplying on top of each other. So therefore, our equation actually becomes this. It becomes yt, which is going to be the y value, is equal to some constant times e raised to the beta coefficient times time with some error term that's multiplied. Unfortunately, working with this model is really not as easy as our linear trends, our linear regression models. But we can convert this to a linear regression model with a little bit of understanding of algebra. Let's look at the log function and e. When we work with the natural constant e, remember that the inverse of e is actually the natural log. Therefore, let's say we have an equation. Yt is equal to e raised to the b power. We can use the natural log to get rid of the natural constant e. So if we took the natural log of both sides, we did ln of yt equals ln of eb, what will then happen is the b will come outside of the log, and this is by rule. So we end up with the same equation as log of yt is equal to beta times the log of e. Now also by rule, because it is the inverse, the log of e is equal to 1. And so therefore we can rewrite our final equation as the log of yt is equal to beta. Now this will help us because we can now use this to help rewrite the equation that we had originally had. So you'll see here that our original equation is yt equals c e raised to the beta times t multiplied by the errors. Using this rule from the previous slide, we can rewrite this as such. Now you'll notice that we have three pieces that are multiplied. We have the c, we have the e raised to the bt, and we have the error term. Another rule of logs is that we can separate out the multiplication of components inside of the log by adding each one of the logged components themselves. So we can therefore break this up into the log of c plus the log of ebt, e raised to the bt, plus the log of et. When we do this, again, we can use our previous rule that will move the bt out in front of the log e, and we end up with what we have, which is log of yt is equal to log of c plus bt times the log of e, which is 1, plus the log of et. And so therefore, alpha is actually represented by the log of c, and our new error term is the log of the error terms, and we're left with bt, or beta times t, in the middle. So we can now interpret this beta coefficient as a percentage change, increase or decrease, with respect to the log of the prediction, and that's our yt. So our yt's are no longer the actual value, it's the log of those actual values. And so we can interpret it, we can interpret the beta coefficient, and we can also get our predictions by simply raising everything back to e. So using a data set for a fictitious stock, the graph to the right shows the high upward curve. Assuming we can take the log of price y, we can create another column with this value. If we then plot the log, it's clear that the log in price down below is linear, and so therefore we can create a linear function associated with it, and that's the second graph below. When we run regression on this, using the log of yt as the predictor variable, we would end up with an equation that's 4.47 plus 0.13t. So if you want to predict future stock prices, remember that the prediction is the log of the stock price. So whatever you get for a prediction, it's actually the power of e. So your future price is going to be equal to e raised to the log of yt, which is how you would write that in Excel using the exp function and the log of yt.